once, all right? Okay, now it should be good. So in about 2 minutes, your friend here should be able to tell you that the audio is back. And I'll just double check. And make sure that the ODS is still working. Yep, it's still working, but this time the audio is definitely showing activity. Good, okay. All right, so here's Prolog. The implementation of Prolog only makes use of one of the quantifiers because you can use one quantifier to implement the other one. Now that part we have already established in the previous class, and the way we did that, I'm just looking for a pen, which we can find here, and then we'll use VLC to take a look at the document camera. Open capture device. There we go. Focused. All right, so last time we have already kind of talked about this. If I say for all x, okay, p of x, p is a predicate, it is really saying the same thing as it is not the case that there exists an x such that p of x is false. Do you guys still kind of vaguely remember this part? Okay, so I'm just trying to get the autofocus to work a little bit better. Okay, I think it's a little bit better than before. So that's why you really technically need one of the quantifiers, because once you have negation, you can use that in conjunction with the only quantifier to express the same thing as the other quantifier. Okay. So once we understand this part, we can go back to the notes. Okay. The universe of this course in Prolog is implied by the use of constants. So let's take a look at this particular sentence and break it down into individual smaller parts. The universe of this course is kind of like the domain. Okay? It's basically the universe or the set of everything that we are concerned about, everything that we want to deal with using this particular system, all the atoms or elements that we want to deal with. Okay, so if we're talking about the Star Wars universe, then we are talking about the droids, we're talking about the Jedis, we're talking about every single being that every single thing, every single being, every single object that is of any interest will be an element of this particular so-called universe of this course. Is that okay? So the universe of this course is a set, okay? And the elements of this particular set represents things that we are concerned about, things that we want to use predicate logic to find out, okay, is this true? Is that true about these particular objects? Is that okay? So that means, individual lightsabers will be a part of this particular universe. Individual robots will be a part of this universe. Individual persons will be a part of this particular universe. Individual hardware, X-Wings, okay, TIE fighters, they will all be, in individual elements of this universe. Is that okay? Okay? All right. And if they are all represented implicitly by constants, constants in Prolog are spelled in lowercase, and they can appear in multiple places. So when we start to read the programs, we'll start to understand what is a constant in a Prolog program. Constants can be quoted strings, can be numbers, can be unquoted strings that start with a lowercase letter. So those are all the things that you can use in Prolog as quote-unquote constants. And these constants define the basic domain of a particular Prolog logic system. In order to handle complex problems, Prolog also has the notation of a list. A list is delimited by the open and closed brackets, the square brackets, which contain items separated by commas. So they're kind of like an array. A list is kind of like an array. But the nice thing about the use of a list is you can use recursion when you're dealing with a list. It is a little bit more cumbersome when you're dealing with an array, because now you have to it's harder to look at an array as one item and the rest of the array, but as a list, it's easier. You just take out the first thing out of the list, and then you say the rest of the list is what I'm going to pass it on. Okay? None of the sample programs that we will be talking about here will deal with lists. So this is really just for your information. Prolog sees any uncoded string that starts with an uppercase letter or underscore to be a variable, so it's case sensitive. The purpose and the use of a variable will be discussed, so we'll talk about it. A predicate in Prolog is an uncoded string that starts with a lowercase letter, such as is a Jedi here is a predicate. And it can be parameterized, even though most of the time it is, sometimes it's not. So in this case, is a Jedi as a predicate is parameterized, and Obi-Wan in this case starts with a lowercase, so it's considered a constant. So in this case, Obi-Wan is a constant, is a Jedi is a predicate, and together it is an assertion that Obi-Wan is a Jedi. Is that okay? Or to use Yoda speak, is a Jedi, Obi-Wan is true. Okay, you guys are not getting that part. You got it? Okay. So you can state individual facts, using this one. So whenever you see a period at the end of a line, it is basically a terminator of this particular predicate. So this predicate is really simple. All it is really saying is Obi-Wan is a Jedi. It's an assertion. Okay, doesn't say anything else. The second one is using the same predicate, is a Jedi, but in this case it is using a different element from the universe. So this time it's saying Luke Skywalker is a Jedi. When you have multiple predicates like these, they are connected by conjunctions. So this one is, so together these two lines are basically saying Obi-Wan is a Jedi and Luke Skywalker is a Jedi. Is that okay? Okay. So you can state individual facts like this by listing, a predicate related to one or more of these, constants. So in this particular example, just looking at these two lines as a Prolog clause, as Prolog clauses, the universe of this course has at least these two elements: Obi-Wan from the first one, and Luke Skywalker as in the second one. Is that okay? Because these are constants, they are used inside a predicate. Two predicates are in M, the interpretation. Is a Jedi Obi-Wan is in M, which is an interpretation, and is a Jedi Luke Skywalker is also in M, which is a interpretation. M is kind of like our iota when we talk about propositional logic. It contains everything that we need to start with. Is that okay? All right? Okay. So now we want to see how we can express some other facts about this universe. So this time, this is the first time we see a predicate that is an implication itself, and it also makes use of variables, or a single variable in this case. How do I know x is a variable? It has to do with, it starts with a uppercase. Very good. Okay, so we remember now in an earlier part that anything that starts with an uppercase without quotes is a variable. So in this case, x is a variable. How do you read this thing? Can use lightsaber, which is basically x can use lightsaber, and then we have a colon dash in between, and then the second part is a Jedi, in parentheses x, and then a period to basically end this particular clause. So what do you think this clause is saying? It is an implication, but which way is the implication going? Which one is implying which one?
Left
Just
implies the right.
It's the other way around. Okay, it is the other way around. X is a Jedi implies X can use lightsaber. Okay, so I know this is kind of opposite to the way we use implication, because in this class when we use implication we always say X implies B, A is on the left hand side, B is on the right hand side. But when you're doing Prolog, it is kind of the opposite. Is a Jedi X in this case is the president, and then the consequent is can use lightsaber. Okay, so together this is, so right here, okay, this clause is the same thing as saying for all X in the universe, is a Jedi X implies can use lightsaber X. And X applies to everything. In other words, you can put in R2D2 into x, the part of x, okay? And this thing will still be true, okay? Because then the next question is R2D2 a Jedi? If it's not stated here, it is automatically not true. So since we do not have a clause that states R2D2 is a Jedi, that means R2D2 is not a Jedi. If R2D2 is not a Jedi, what about R2D2 is a Jedi implies R2D2 can use lightsaber? Would that be a true statement or a false statement? We already know that R2D2 is not a Jedi. So that would make it a true statement because it's an implication. With an implication, if the first part of the precedent is false, the implication itself is true. Gotta remember that part. Okay, let me say that one more time. Because we do not have a fact stating that R2D2 is a Jedi. In prologue, if you do not say that, then implicitly you're saying R2D2 is not a Jedi. So R2D2 is not a Jedi, which means the first part of the implication is false to begin with. So what can we say about the entire implication? The implication itself is true. Okay, so we have to remember this table. Okay, remember the table of implication, the truth table. So this is what we need to kind of go back to, from time to time because it is really important. So this is P, this is Q, and this is P implies Q. P can be a predicate, can be a proposition, can be a variable, can be whatever. Okay, but P is Boolean, can be true, can be false, can be true. When P is false, Q can be false, true. When P is true, Q can be false, true. Okay, so we want to find out, when P is false, Q is false, what is P implies Q. But we don't have to look at P implies Q by itself as a new operator, or implication is not really a new operator, because this is really the same thing as not P or Q, because that is by definition. Implication is, okay, P implies Q is by definition not P or Q. But because of the not P, so that means every single time P is false to begin with, the implication as a whole has to be true. In other words, I know for sure that these have to be true even without looking at Q. Is that making any sense so far? Okay, just because of the definition, the way implication itself is defined. The only time the implication can be false is this one. When P is true but Q is false, that's the only time an implication is false. That's the only time P implies Q is false. And then P implies Q is true again when P and Q are both true. Is that okay? So this is a really important table to remember because a lot of stuff that we have talked about so far, including the properties of functions, properties of relations and whatnot, relies on your understanding of implication. And a lot of times we use this to guard a condition. In other words, the first one, okay, in this case, the component P is called, is used as a guard condition. It's basically saying, well, if R2D2 is not a Jedi, we don't even care whether R2D2 can use a lightsaber or not. It is already a truth in this universe. Is that okay? Are you guys relating what we are talking about on the screen, on the document camera? There we go. On the document camera to this particular statement here. Is a Jedi X implies can use lightsaber. So this part here, X is a Jedi, can be seen as a guard condition. In other words, if X is not even a Jedi, then I don't even care whether X can use a lightsaber or not, because the implication itself is already true. Okay? On the other hand, if X is a Jedi, then we can make the conclusion that, oh, we know that X can use a lightsaber. Is that okay? All right, so let's go ahead and give this a try. Okay, I'm hoping that I have included Prolog into this particular distribution of my Debian. So we'll go ahead and, okay, yep, it is included. That's cool. So we'll go ahead and start with the program. Okay, so I just call this one sw.pl for Star Wars.pl, Prolog. And we'll go ahead and type in that particular code. is a Jedi, and then we have Obi-Wan, and with a period, okay? Now, there's actually an implicit implication here. In other words, every single time I type something like this, it is really the shorthand of saying true implies Obi-Wan is a Jedi. Okay, it's just a shorthand. Okay, so if I say true implies Obi-Wan is a Jedi, is it saying the same thing as Obi-Wan is a Jedi? If I say the implication itself is true, and then I say the implication is true implies Obi-Wan is a Jedi, is it really saying the same thing as simply saying Obi-Wan is a Jedi? How do we draw that relationship? And I think true has to be lowercase because it is a constant. Okay? So the question, okay, let me restate my question. Okay, this is going to be a period here. So my question is, are these two clauses really saying the same thing? One is simply saying true implies Obi-Wan is a Jedi, and then the other one is saying Obi-Wan is a Jedi is true. Are they saying the same thing?
Yeah.
Well, and let's use our truth table to take a look. Okay. So flipping to the next page, switching back to the document camera. All right. So we'll spell it out. Okay. So we'll have here P and Q again, but this time P. Okay, P implies Q, but this time P is already known to be just the constant of true. Okay. In other words, we're only dealing with the cases when P is a 1 because we already know we're dealing with true implies something. And then what is Q? Q is Obi-Wan is a Jedi. So we are saying Obi-Wan is a Jedi. Okay? And one thing that we also know is the implication itself is true. When you look at the implication itself, it is true. So if I go back and use the other slide that we have already used, and I'm going to fold it so that we only look at the part that is relevant. Okay, so there we go. So when we look at the entire implication, the whole implication is true. In other words, we should focus on these 3 rows where the implication itself is true. Is that okay? Yes, go ahead.
So in prologue, is it always true that the implication is true?
Yes, everything that you state in the prologue, quote-unquote, program, you're stating whatever is true. You're only stating what is true, and what else, the stuff that is not true is implicit. So anything that is not stated as true is automatically false. Is that okay? All right. So now getting back to this example here, because we know this implication is true because we only state true clauses in the prologue program. That means we only pay attention to the first, second, and the fourth row, because only these 3 rows have the entire implication itself being true. But because we also know this component, P itself, is a 1, so we know that we don't need to take a look at the first or the second row because those correspond to the cases where P itself is false, but we know P is true, so now we focus on the last row. When you focus on the last row, and you know that the implication is true, you know P is true, that means automatically Q is also true. Q in this case is Obi-Wan is a Jedi, or in prologue notation is a Jedi, in parentheses Obi-Wan is true. So the shorthand is really just what it is. It's just a shorthand. When we type it in a program like this, these 2 lines represent exactly the same thing. Is that okay? All right. So we'll go ahead and type this one, and then we'll type is a Jedi. Luke Skywalker, like that. And what is R2-D2? Is he called a maintenance droid or a droid? Maintenance droid. But so it's a droid, and on top of that he maintains. So we'll just say is a droid R2-D2. Okay, so we'll call this entire program. Okay, this is just the entire program. And then we'll exit from this, start up the Prolog engine, and then we have to read in the program, which I have forgotten how to do. I think it's a single quote, but I cannot remember for sure. Help topic. So let's try a single quote. sw.pl. Nope, that's not what it is. Cannot remember how to read in a program in Prolog. That's easy to find out. SWI Prolog. Getting started. And by the way, if you really want to learn about Prolog, this is a great website because it actually gives you a lot of instructions of how to write your own programs. Okay. Starting, executing, initializing files. Okay, there we go. In square brackets. Okay, there we go. All right, so in square brackets, we type in the name of the program, and a period, in quotes. Yep, there we go. So it just read the whole program in. Now we can start to ask questions. Okay, so this is really the fun part of it. You can ask, is a Jedi R2-D2? And it says it's false. Because R2-D2 is never known as a Jedi. It's never stated here that R2-D2 is a Jedi. So you can also ask whether Obi-Wan is a droid or not. That's going to be false as well. Is a droid Obi-Wan? That's also false. But you can also ask whether Obi-Wan is a Jedi, because we already know that should be a fact. So you say it's a Jedi and an Obi-Wan, and it tells you it's true. Is that okay so far? Kind of cool. You can also ask it questions like this. Who is a Jedi? And it tells you there's a continuation, which is a space. Okay, so when you try to answer a question like this, it would actually try to figure out all the things in this universe that are Jedis. So in this case, it would just tell you, okay, the first one that is known to be a Jedi is Obi-Wan. In other words, when X is Obi-Wan, this predicate becomes true. But it will also search through all the other elements and will try to fit in Luke Skywalker. When we put Luke Skywalker in the place of X, is a Jedi as a predicate is once again true. Are we doing okay so far? Okay. All right. So this is a very simplistic program, but we can start to see some really powerful feature of Prolog already. So let's go ahead and terminate the program. Go back to our notes here. Go back to this part of our notes. So now we can start to state some other facts. Okay. Predicates can use any number of parameters. In this case, owns is a way for me to connect objects to the owner of the object. So owns, and then in parentheses, Luke Skywalker, comma green hack, basically states that Luke Skywalker owns green hack as a lightsaber, as an object. Okay. Now whether green hack is a lightsaber or not is handled by line 3, which is just a single predicate that is stating green hack is a lightsaber. Okay. So we'll put in these 4 lines of code into the program. Okay, so let's go ahead and edit the program. Are there any questions at this point? Questions? Okay. So we'll type owns Luke Skywalker green hack. There we go. Owns Obi-Wan blue classic 3. Do you guys pay attention when you watch the movie? Do you pay attention to the color of the lightsabers? Sort of. And then we say is a lightsaber green hack is a lightsaber. Blue classic 3. Okay. All right. So this is now our kind of longer program. So we can definitely check whether who owns which thing, and we can also basically ask the question in a reverse order, and we can say, oh, we know green hack is owned by somebody. Who owns it? We can ask questions in that manner as well. So let's go ahead and check that out first, and then we'll come back and look at this sw.pl quote and bracket period. Okay, so now we can start to ask those questions. Yep.
Can you kind of go over what owns is actually doing as a multi-parameter predicate?
Say that one more time.
Can you go over what owns is actually doing as a multi-parameter predicate?
You mean this one here?
Yeah. Like in terms of like how the implications and stuff will work. Because like I get
it simply means this particular predicate is true. In other words, when the first parameter is Luke Skywalker and the second parameter is green hack, then the owns predicate is true.
Okay, so Obi-Wan, green hack would be untrue?
Would be false, because there's no fact or no implication that can derive that it is true. So anything that cannot be derived as true and terminates will be known as false. Okay, so we can give it a try. So now that we're in prologue, we can start to ask them questions. Okay, so that's a good question that you just asked a little bit earlier. So can we ask this question? Owns Obi-Wan green hack and then period. Okay, and it says it's false because there's nothing supporting this particular predicate being true. Is that okay? Yep, go ahead.
Can you like create multiple modules where they have like their own universe?
Say that one more time.
Like how would you create multiple universes? Would it be just like multiple modules?
They all, everything inside the same program, they have to share quote unquote the same universe. Okay, but we can also ask the question in a different way. You can say, what does Obi-Wan own? So you can ask a question like that, where in the predicate, the first one is a constant and the second one is a variable. In other words, we know the person, we know the owner, we just want to know what objects are owned by this particular owner. When you press the enter key, in this case, there's only one thing that Obi-Wan owns, which is Blue Classic 3. Is that okay? Yep, go ahead.
Could you put it in like who owns the lightsaber, so you know the name of the lightsaber? So
Yes, you can do it too. You can do that too, because the ordering of the parameters doesn't really matter. It's just a position, so you can ask questions about any parameter that you want. So you can now say, who owns green hack? Okay, and it says it's Luke Skywalker. Yep.
If you put owns green hack, X.
Then it would just say false because because green hack is not the owner of any kind.
Okay, so it is sensitive to the ordering.
Yeah. So if you say it like this, then we'll just return false because green hack does not own anything. There was a question. Yeah, go ahead.
Can you use two constants?
You mean two variables?
Yeah.
Okay. And if the answer is yes, it will give you both cases. So in the first case, if you use Luke Skywalker as X, green hack as Y, that predicate is true. If you use Obi-Wan as X, Blue Classic 3 as Y, that predicate is true as well. And you had a question? Yeah.
Is owns a reserved keyword, or can you
Nope.
use anything like that
It's
makes sense?
yeah, you can name your predicate any way you want.
As long as it just has two.
It has to
parameters.
start with a lowercase character, and you can have any number of parameters. Yep, go ahead.
If we added owns parenthesis green hack parenthesis, then could we put like how you had owns X, Y?
Mm-hmm.
If you had the same variable for both.
Yes, you can do that
for
too.
X, X.
Yep. In that case, it will only return one single predicate that fits that description where both parameters are the same.
Okay.
Yep. Okay. So are there any questions about Prolog or this particular sample program at this point? Yep. Mhm.
So what exactly is a constant? Is it just the statement itself?
The constants refer to everything that starts with a lowercase that is not the name of a predicate is a constant,
Okay.
which is representing an element of that universe. Okay? Are we still doing okay so far with predicate calculus in the form implemented as Prolog? Okay. All right. So now we start to get into something that's a little bit more complicated. Okay. So what we want to express now is for all x, for everything in this particular universe, if x is a Jedi, that implies x should own a lightsaber. Okay, so let's check out this statement here. When we use a notation like this for all x, that means we are binding x to a particular thing in the universe for the rest of this thing to be evaluated. In fact, we're binding it to every single thing. Okay, so this whatever we're expressing here to the right-hand side of the for all, we're basically saying this thing should be true no matter which x you bind it to, as long as x is an element of that universe. This entire highlighted expression has to be true. Okay? So once we bind x, then we basically look at x, or look at this particular predicate with x already bound to one thing and say, okay, let's first check whether x is a Jedi. If x is not a Jedi, then the implication is already true and there's no need to go any further. Okay? On the other hand, if x is a Jedi, then we want to evaluate whatever is to the right-hand side of the implication. In other words, we'll have to evaluate this part when x is in fact a Jedi. Is that part okay? Because now it's just really the property of an implication. So with the highlighted portion here, what is it saying? Now it's saying for there exists. Okay? It says there exists a y, some y in this universe, such that x, which is already bound at this point. In other words, x is already stuck with a particular thing in that universe that is known to be a Jedi. Okay? So with x already bound being a particular thing that is known to be a Jedi, we want to find out is there at least one thing y in this universe such that x owns y and y is also a lightsaber. Okay. So in order to express this particular rule, we'll do it like this. So we'll say, is a proper Jedi one is, first of all, is a Jedi and owns x, y, and y is a lightsaber. So I am using this particular predicate here is a proper Jedi one to express, okay, in order for x to be a proper Jedi, x has to be a Jedi first, owns a light and also owns a lightsaber. Is that okay? All right. Okay. So let's go ahead and kind of tweak our program a little bit to test this particular rule and see who is a proper Jedi and can we come up with an example of someone who is a Jedi but is not a proper Jedi. Okay. So we'll go ahead and edit the file again, and this time we specify this rule, which is a proper Jedi 1, and we use the variable x only if x is a Jedi, x owns something, y, and that something y is known as a lightsaber. Okay. So this is how we specify a rule, and remember the importance of reading this rule is you have to read it backwards. In other words, x is a Jedi and x owns y and y is a lightsaber implies x is a proper Jedi 1. Because I'm going to have another one to have another qualification of what I consider as a proper Jedi. Okay, the next one is going to be a little bit more complicated, but this one. So do you see how y is just on the right hand side of the rule, but not on the left hand side of the rule? anything that is on the left, any variable that appears on the left-hand side of the rule is automatically assumed to use the for all quantifier. Okay, let me say that one more time. When you look at the rule, this is the left-hand side because it's to the left-hand side of the colon dash. Any variable that is appearing on this side, which is the highlighted portion, in this case we only have uppercase X here, that is a for all. In other words, you don't spell out for all. It is just implicit when a variable is on the left-hand side of a rule. If you have anything that is in addition to the variable on the right-hand side, which in this case is the variable y here, it is implicitly a there exists. Is that okay? So this entire rule is really saying for all x, because x appears on this side, for all x, if x is a Jedi and there exists y, where x owns y and y is a lightsaber, that implies x is a proper Jedi. Is that okay? All right. So let's go ahead and specify this rule. Oh, we have to give us a non-proper Jedi. So a non-proper Jedi is going to be a Jedi. Okay, which Jedi does not own a lightsaber? Yoda has one.
There was the gray Jedi from Rogue One who just had the staff.
Okay, has a staff that doesn't light up?
No, it was the monk from Rogue One. I forget his name though.
Okay, so we'll just say that monk from Rome.
Was he?
Hmm?
Here's the monk that thinks the Force is.
Jar Jar Binks is not even a Jedi. He's a Sith.
The guy with the gun, the Jabba Fett, what's his name? What's his name?
Well, plus it doesn't use like the proper crystal.
I can see the class is now having a more lively discussion now that we are moving slightly away from the predicate calculus. It's okay. Okay, so we'll just say monk from Rogue One is a Jedi, but there's no ownership here. Okay, no ownership of a lightsaber established. Okay, all right. And he can. I mean, this monk can own some other things, like monk from Rogue One can own a staff, dirty staff. Okay, okay, and then we can say is a is made of wood, dirty staff. Okay, so dirty staff is something, but it's not a lightsaber. Okay, it can be many things, but it's not a lightsaber. All right, so we'll go ahead and test our program. SWIPL, reading the whole program. Okay, let me move this up so you can see a little bit better. Okay, okay. It complains about clauses of is a Jedi / one are not together in the source file. Earlier definition, on line 1. Okay. Oh, okay. It wants everything to be together. Okay, I can see why. Okay, what it's complaining about is they're not bunched together. Okay, so stylistically speaking, it is not good because it means sometimes you lose track of all the facts. So it wants to group everything in the particular order. Well, that's fine. Okay, not a problem. So we'll do another game. Try another run. No complaints this time. Okay, so now this time I want to see who is a proper Jedi. Okay, so we say is a proper Jedi 1, and then just put X here. In other words, I'm just saying, okay, tell me who is a proper Jedi. So I press the Enter key. The first one is Obi-Wan. Second one is Luke Skywalker, and that's it. Okay, but it says false at the end, and basically it's saying, okay, I have just run out of all the proper Jedis. Is that okay? And of course, you can also say, ownership. Okay, owns XY. Who owns what? Okay. Then it says, Luke Skywalker owns Green Hack. Obi-Wan owns Blue Classic 3, and Monk from Rogue One owns Dirty Staff. Is that okay? So it's kind of cool. Okay. So the next one is going to be even a bigger challenge. Okay. Now the next one is a bigger challenge because I want to express that as a proper Jedi, a proper Jedi cannot agree with a Sith. Okay, Jedis and Siths, do not have agreements. That's what I want to express. Okay, so the question now is, how do we express that? So we'll start to introduce, sets, in this case. So the first one is a rule that seems to be right, but it's not. Okay, so we'll check out this rule here and then we'll try to analyze and say, why is this not correct? Is a proper Jedi too, okay? In other words, this is the second criterion to be a proper Jedi. Is X has to be a Jedi, X has to disagree with at least one Sith, and Y. Okay, X has to disagree with at least one thing, which is Y, and Y has to be a Sith. Is that okay? So remember the for all and the there exists thing, okay? So which variable is implicitly a for all in this particular rule?
X.
X is implicitly a for all because it appears only on the left-hand side, okay? But Y is also a variable, but it only appears on the right-hand side. So that will make it a there exists, okay? So in other words, this is really saying for all X has to be a Jedi, and X has to disagree with at least one Y, and that Y has to be a Sith. So that means, in order to be a proper Jedi in this case, a Jedi only has to disagree with one Sith, not every single one. But that's not what I want to express. I want to say that in order to be a proper Jedi, the Jedi has to disagree with all the Siths. Is that okay? So now the question is, how do we express that? Because whatever variable that appears on the right-hand side that is not on the left-hand side is automatically a there exists. So this is where we use that particular rule. Okay, I'm hoping you guys still remember that rule. Okay, I'm switching back to the document camera here. And since I have it already written, we're going to make use of the companion of this rule. Okay, because this rule is only one part of it. The other part is you can also express there exists X such that P of X is true. It's really saying the same thing as it is not the case that for all X that P of X is false. So we're going to use this trick here, okay, to get us our for all that is going to be on the right-hand side. Is that okay? Because unless we use this trick here, all the variables that only appear on the right-hand side are automatically there exist, which is not what I want to express. So to get this done, what we do first is we'll have a predicate. I just called it Sith tolerant. Okay, so Sith tolerance has to do with there exists a Y that is a Sith. And this particular symbol means not, okay? This is actually logical negation, such that it is not the case that X agrees with Y. In other words, X does not agree with Y is what this part is saying. Are we doing okay so far? So together what it means is, if Y is a Sith and X does not disagree with Y, then X is Sith tolerant. Yep. It's double negation.
So that's the same thing if you say agree with.
Yes.
Then why do you have to use the double negation?
Well, because I only want to use a predicate to indicate who disagrees with whom. So it depends on which one do you want to be implicit. Do you want to have agreement as implicit, or do you want to have disagreement as implicit? Do you see what I mean? Because if it is not disagree, then it is agree. So it depends on which one is more important, which one is what you want to state explicitly. Okay. So once I have this rule, which is X is Sith tolerant, then we can now say, X is a Jedi, X is not Sith tolerant. If both of these conditions are met, then X is a proper Jedi. Are we doing okay so far with this? So the double negation that you saw on the document camera, okay, remember the double negation here? Here's one negation, and here's another negation. We can find both of those negations in the code, because here is one negation, and here's the other negation. Is that part okay? So in order for this program to illustrate the code that we are talking about here, we'll have to start to introduce predicates to indicate who is a Sith, okay, and who disagrees with who. But with those, we can start to analyze and say, okay, who is a proper Jedi according to this particular criterion? Any questions about this part? Okay, let's go ahead and check it out, okay? Because I would definitely want to check it out. Okay, so we'll go ahead and terminate prologue, go back to the program, and then we'll start to state who is a Sith. Is a Sith. Okay. Darth Vader is probably one of the more well-known ones, right? Okay. And we'll have one more. Darth Maul. Okay. How do you spell Maul? M-U-L. Maul.
Yeah.
And he did not die from episode 1, right? I think there are alternative storylines where he was brought back to life after he got chopped into half in episode 1.
Hey, he's still alive.
Mhm.
He's in Clone Wars.
Okay. So now we also have to state who disagrees with whom. Okay. So we can have disagree with. Okay. So we'll say Obi-Wan disagrees with Darth Vader. Obi-Wan also disagrees with Darth Maul. And with Luke, he only disagrees with Darth Maul because the other one is his daddy. Who's your daddy? I've seen T-shirts like that, with a Darth Vader, and then it says, who's your daddy? Yep.
The disagrees with.
Mm-hmm.
If you want, is there any way you could put Obi-Wan disagrees with Darth Maul or Maul and Vader in like one line, or do you have to do it with two distinct predicate clauses?
You have to do it with two.
But isn't it just saying the same thing but it's a different person? So why wouldn't there be a way to be able to do it, like make a list of people that Obi-Wan disagrees with without calling it multiple times?
Okay, I'm just trying to find out whether there's a way to express that using a list. I suppose you can make a list and just say disagrees with, and then you have a list. But then that becomes the format. Okay, disagrees with is expecting a list. Okay.
So I've got a question about that then.
Yeah.
Could you not pass the predicate as a parameter?
Say that one more time.
Could you not pass the predicate is a Sith as a parameter? Like instead of putting Obi-Wan, Darth Vader, you just put Obi-Wan, is a Sith?
You cannot do that.
No?
Nope,
Okay.
nope. You can turn, okay, so whatever is on the left-hand side of the implication, the things inside the parameters can either be a constant, a list, or a variable. So it cannot be a predicate inside it. Now you can express it on the other side, but the problem with expressing it on the other side is the new variable that you introduce is automatically a there exists quantifier. Now let's figure out what this is going to mean. Okay, so we'll turn this one around a little bit because this is actually okay. This is valid syntax, but the question is, what does it mean? Okay, is a sith x. Okay, so let's look at this line here and try to figure out what does it mean. Now just have to remember you have to read it backwards. Okay, so this is basically saying if x is a sith, then x only one automatically disagrees with x. Okay? And that rule by itself should automatically make only one a proper Jedi. Right? So we'll plug it in and see whether that is the case. And then we'll keep the other one, which is Luke Skywalker just disagrees with Darth Maul. Okay? So now we have to implement the actual rule to specify who is a proper Jedi. So is a proper Jedi to X here. So X has to be a Jedi first. X is a Jedi. We're missing the other one, which is a Sith tolerant. Sith tolerant X. So we need a is a Sith Y, and it is not the case. Okay, I'm just looking at the syntax here. Yep, backslash x backslash plus. It is not the case. Disagree with XY. There we go. So in order for X to be a proper Jedi, X has to be a Jedi, and X cannot be Sith tolerant. So we have Sith tolerant X here. Okay, there we go. Okay. So now we go into the Prolog engine, read the file in, and then we can start to ask some questions. Okay. So we can say who is Sith tolerant? Sith tolerant X. And it says nobody is Sith tolerant. That's not right. Okay, that's true. Let's try Obi-Wan. Obi-Wan is not Sith tolerant. Let's try the monk. The monk is Sith tolerant because we have not stated that he disagrees with anyone. Is that okay? Obi-Wan is the only one that is not Sith tolerant because we have explicitly stated that if Y is a Sith, then Obi-Wan disagrees with that. Why? Yep.
Why did Sith tolerant perimeter X not accept Luke Skywalker? Because he's not tolerant to all Sith?
That's correct.
Okay.
Because Luke Skywalker disagreed with Darth Maul, but there's nothing that says he disagrees with Darth Vader.
But I guess what I'm trying to understand is like why it put false. So it put false because he disagrees with Darth Maul.
Oh, you mean the second part? You mean after?
Right above it.
I mean here?
Yeah. So it put false because he doesn't agree with all Sith?
Okay, this has to do with the rule matching part here because it just cannot find a instance to. It depends on how we specify Sith tolerant. So in this case, we specify Sith tolerant to be like this first, and that's why it cannot find an X to meet that requirement, because it will first pick up a particular Y, which is a Sith, and then it will try to evaluate this part here.
So if we were to put that in the reverse order, where it was disagrees with and then is a Sith,
I believe so. So let's go ahead and give it a try. That's a good question. The order of these things, can be important. I'm not 100% sure it is the case here. SW.pl. Oh, okay, it doesn't like it. It's a warning, it's not an error, but it is saying, singleton variable in \x, which means y has not been bound to anything yet, and yet it is used in a negation. It doesn't like to do that because in a negation, it's looking for the lack of something. So that's why it doesn't like that, because it needs both x and y to be bound to something. Then you can just check, okay, is that fact not established? So the order is important. So let's switch the order back.
What would happen if you still ran it though, even with the warning?
Well, let's give it a try, and then we'll try to explain the behavior. Okay, so we'll do the same thing. Is cisp tolerant. There we go. And put the x here. It still returns false. And we'll check whether school. Okay, so this time it says Luke Skywalker is not cisp tolerant, which is the same as last time. This is actually correct. We'll try Obi-Wan here, and this is incorrect because Obi-Wan should not be. Oh, Luke Skywalker is not cisp tolerant, so the first answer is incorrect. This one is incorrect, and I think it will return with everyone being not cisp tolerant. Okay. What about R2D2? Have we stated anything about R2D2 being disagreeing with anyone? No, he agrees with everybody implicitly, right? But it will just come back as false as well. Oh, it does return as true. So Luke Skywalker has, okay, what about the monk? It's going to return as true because with Skywalker, it finds a particular instance. Okay. It has to do with how negation is handled. So let's go back to here. So when you evaluate it in this particular order, in order for something to be cisp tolerant, it will first bind this x to whatever you're checking with. So let's say we're checking Luke Skywalker. So x is automatically bound with Luke Skywalker. And then what it will try to do is to evaluate the negation of disagree with x already known as Luke Skywalker. Is that okay? And because we know x is Luke Skywalker already, it will go through all the facts that we have already established, and this is the only one that meets that requirement. So then it will come back and say, oh, okay, with the only rule that we know about who Luke is disagreeing with, we already find a particular instance that Luke is disagreeing with Darth Maul. So that will satisfy the thing inside the negation. In other words, we made this true already. Is that okay? And the moment you made that true, the negation turns it into false.
So it never even checks Darth Vader because it's not associating with Luke?
So-
So it never checks Darth Vader because it's not associating that with Luke because they're
Correct.
not. Okay.
Yep. So basically it just negates the whole thing, and it automatically says that Luke is not cisp tolerant because because we put it like this.
So would that be an error with the way that so is the logic correct, but the way that the software runs is like
Incorrect. Yeah, because the order of the binding matters. Now, if you do it the opposite way, okay, reverse the order again. So we look for is a cisp first, okay. So okay, so with the second rule, the first thing it binds is x, okay, because it's just saying okay, because we specifically ask is Luke Skywalker cisp tolerant, okay, so x is already bound to Luke Skywalker, and then it will look at this rule here, which is a there exist, right? So it would look at okay as a cisp, and there are multiple items that are known as cisps. So it will first look at the first one, which is Darth Vader. Yep.
So just to so you can overload predicates like that? Like you have two predicates.
Yes.
How does that handle like
It becomes an or.
okay, so it uses just so if either of those is true, it uses
Yes.
or. Okay.
So any predicate of exactly the same name, then the clauses are connected by ors.
Okay.
So now you have so in this case, you're binding you're binding y with a cisp first. So the first one is going to bind to is Darth Vader, and then it will check whether x disagrees with Darth Vader. There's no evidence that x or Luke Skywalker disagrees with Darth Vader, so this becomes false. But if this is false, then the negation becomes true, and that's why it returns true initially. And then it will go back and try to bind y again to something else, which in this case it will bind to Darth Maul. And Luke does disagree with Darth Maul, which means this part is true, which means the negation is false, but because all the components inside this part are connected by a conjunction, so if one thing is false, then the entire thing is automatically false. So it does matter, which way, the ordering of the binding matters. Yep.
What if you wanted to combine the components with the disjunction instead of conjunction? Can you do that? So like, if it is a sin, then what is it going to look like? A disagreement anymore? Because if you already look at something that's a sin, you should already know that they're still tolerant. Right?
Say that one more time.
Is there any way to combine the components with a disjunction instead of a conjunction, or does it automatically, like the format is do conjunction? So instead of saying it has to be is a sin, y, and
Right.
does not disagree with x,
I
y?
think a semicolon denotes disjunction, so you can have all the commas and then a semicolon, and I'm just gonna double check that. Prologue, disjunction. Yep, it's a semicolon. So this particular rule, option 2, is saying rich or famous implies happy. This is a conjunction, which means rich and famous implies happy. This is also a disjunction. This is another way to express disjunction. Basically, rich implies happy, or famous implies happy. So you have the alternatives to express the same thing. Is that okay? All right, so now that we have it back here, we want to find out who's a proper Jedi. So we'll find out who's a proper Jedi here. Is a proper Jedi 2. Who is a proper Jedi? Obi-Wan is, and nobody else is. Which is correct, you got it right. Luke is not a proper Jedi because he is tolerant of his own father. Despite his getting his hand chopped off by his father, he's still tolerant. And then the monk does not disagree with anyone, so automatically he is tolerant. What about R2D2? Okay, let's check one more thing. Why is R2D2 not on this list? Because R2D2 does not disagree with anyone either, but it fails one particular predicate automatically. He's not a Jedi. R2D2 is not a Jedi, so it does not qualify as a proper Jedi automatically. Okay, so we are running out of time today. Next Tuesday, we're going to continue with this discussion, but on Tuesday, what we'll do is we'll look at the underlying mechanism that makes predicate logic work. Okay, so today we just kind of explore the rules and go like, oh, we can express rules like this, and we can do inference, based on those rules. On next Tuesday, we're going to look at the underlying rules or the underlying mechanisms called substitution that actually makes this whole thing work. right, have a nice weekend. I'll see you guys next Tuesday.
Yes.